Hello everyone. Today we will discuss about tree in data structure section. Tree is look like an originally tree which is situated from the downside to upside. That looks like a tree which is in the inverse position. A tree is a possible of nonlinear data structure which is made up with nodes and vertex and edges without having a cycle. That means here we have nodes, those are all nodes, and those lines are known as edges. But there is no cycle. That means it starts from 2 but cannot never get back to this position 2. So that's why tree is not a cycle. This is a very important, and the tree with no nodes is called the none or empty tree. Here is the structure of a tree. Here is the first element is known as the root node, then the intermediate nodes, and last node is known as the leaf nodes. Now the binary tree. In this section here we have T is empty, null tree or empty tree. Tree contains a distinguished node which is R is called the root of T, and in this section of binary tree we can have two sections T1 and 2 because we have already discussed that this is binary. In this binary we can have two sections 0 or 1. Algebraic expression. In this expression we have E equals to A minus B divided by C into D plus E. First of all, we need to generate the bracket section. We need to apply the formula of Badmash here. Here, first apply the bracket sections, which is C into D and A minus B. Here A minus B is created and C into D is created here. After that, in the second bracket we have C into D plus E. That is why this multiplication answer will be added by the E in this section, and finally those both sides are divided, which is the root section. So that is how we explain this formula with this algebraic expression of tree. Classifications of binary tree: complete binary tree and skewed binary tree. A complete binary tree is a full binary tree, sometimes a proper binary tree or two trees. In this tree, which every node or other than the leaves have two childs. That is why in this diagram you can see that A have two childs, B and C have two, and D have also two. That is why it is known as the complete tree. But in extended binary tree, a binary tree is said to be the two tree or extended binary tree if each node have either 0 or two children. In this reason, you can see that this one is a normal binary tree, but this section is extended binary tree because they can have either children 0 or 2. In this section these have two children's. That is why they can have 0 children or 2 children. That is why it is known as the extended 2 binary tree. A representation of binary tree in memory. Those can be linked representation and sequential representation. In linked representation, those can be linked by this one that we have already discussed in the linked list section. Here we have information section, the left section, right section, and the root. Here is the root section, and then which is situated on A, and on the left side of A we have B, and right side of A we have C. So that is how we can define the linked representation of tree. This is also a table of information and their left and right sides. C and B have nothing on their left and right side, but in A section A have 4, which is the value of B, and right section it have C, which is the value of 5. Now the sequential representation. Sequential representation means the general representation. Here are some points of sequential representation. Pre-order, in-order, and post-order are also similar to infix, prefix, and postfix that we have already discussed. Traversing binary trees can be done by those 3 steps. In prefix, first we need to go to the root, and then left, then right. In pre-order, we can go traverse the left section, then right, and lastly the root section. In order section, we need to visit the root in the middle point. That's why it is known as in order. Left first, then root, and then finally the right one. Here are some disadvantages and advantages of tree. You can have a snap of this one. That's for today. Thank you.